Unscaled Postgres often hits bottlenecks under heavy load, causing slow queries and potential downtime. These issues arise because This lesson explores Postgres sharding, replication, and connection pooling, key techniques to overcome scaling, availability, and consistency challenges in high-throughput production systems handling millions of queries daily. Sharding horizontally partitions data across multiple Postgres instances, distributing load and storage. This boosts scalability but requires intelligent query routing and complicates transactions spanning multiple shards in production. Replication maintains copies of data on standby nodes for fault tolerance. Synchronous replication guarantees data consistency at the cost of higher latency, while asynchronous replication offers better performance but risks data loss during failovers. In Postgres config, setting synchronous commit on waits for standby replicas to confirm writes, ensuring durability. Setting it to off reduces latency but risks data loss. Use synchronous standby names to define which replicas are synchronous. Connection pooling reuses established database connections, reducing overhead and avoiding exhausting Postgres's connection limits. Properly sizing the pool improves throughput and lowers latency during peak concurrent workloads. Tune connection pools by capping maximum connections to prevent DB overload, setting idle timeouts to close unused connections promptly, and continuously monitoring metrics to detect leaks or bottlenecks early in production. Cross-shard joins complicate queries and increase latency because data must be aggregated outside the database. Designing schemas to localize related data within shards minimizes these costly operations and improves query performance. Minimize cross-shard joins by sharding on stable keys like tenant or user ID, denormalizing data where it reduces complexity, and offloading complex join logic to the application layer for better scalability. Replication lag causes read replicas to return stale data, risking inconsistency in reads. Critical reads should always target the primary node, while replicas are best suited for reporting or eventual consistency use cases. Connection pool exhaustion leads to queued queries, increasing latency and causing timeouts. Monitor pool usage closely and adjust pool size based on workload patterns and Postgres capacity to avoid bottlenecks. Example using TypeScript PG pool. Configure max connections, idle timeout, millis to close idle connections after 30 seconds, and connection timeout millis to fail fast if connection cannot be established within 2 seconds, optimizing resource use. Schema migrations across multiple shards require careful coordination to avoid schema drift or downtime. Run migrations sequentially and verify schema consistency across all shards before resuming normal operations. Production best practices include sharding on stable keys to avoid resharding, monitoring replication lag to maintain data freshness, tuning connection pools for concurrency, and automating migrations to ensure system reliability. Balancing consistency and latency is critical. Sharding and replication introduce trade-offs that affect system responsiveness and data correctness, requiring careful tuning to meet application SLAs under load. To recap, shard data to distribute load effectively, choose replication modes balancing speed and consistency, configure connection pools for concurrency, and automate migrations to ensure stability in production environments. If this lesson helped you understand Postgres scaling strategies, please subscribe and check the lesson notes for the full production-ready checklist to implement these techniques effectively. If this helped, subscribe and open the lesson notes for the full checklist.